Hello everyone! Ever wondered how different concepts overlap or where they perfectly match? In today's video, we are diving into the fascinating world of Venn diagrams, a simple yet a powerful way to visualize relationship between sets. Let's explore how these overlapping of the circles can help us better to understand the complex ideas with clarity and precision. So stay tuned with us and do not forget to like, share and subscribe to our channel. Hello students, welcome to yet another exciting topic, sets and Venn diagrams. Let's get started with the topic for your understanding. So what sets and Venn diagrams represent? So set is basically well-defined objects collection, okay, and these are represented with the curly braces. And if we are representing sets in the pictorial manner, then these are called as the Venn diagram, as you can see here. Okay, so we have to say about the order of the sets. What order of the sets means? Order of the sets means that how many number of elements are there in a set. So if I am writing number of elements as 1, 2, 3 and 4, so cardinality is defined as number of elements in the set, which will be as number 4. Number 4 means total number of values in the sets. Okay, so here you can see that if we are denoting n bracket A, so it represents the number of elements present in the set A. Okay, so this is a Venn diagram as shown. So there are two sets A and B. Okay, so this portion that is marked shows that these objects are in set A but not are in set B. Similarly, this area represents what? This area represents the elements that are present in B but not in A. The middle section or the intersection area is called as A intersection B, means the common area that A and B both share. Okay, this, as you can see, is the whole area that comprises of both A and B, and we represent it with the symbol psi, and this represents the whole universal set. So what universal set is? Universal set comprises of both the sets or the complete set area. You can note these down and then we'll proceed further. Okay students, I hope you have found the basics of Venn diagrams and sets. Now let's discuss how many forms are there to represent a set. First is a statement form. So as you can already see that we can write a statement and then represent a set. For instance, you can see that the set of odd numbers less than 13. We can write it as even numbers less than 13. So this will represent the same which the question has been asked for. Okay. The other one is roster form. In roster form, what we do, students, in roster form we represent all the elements. For instance, I am saying first 3 prime numbers. So what 3 prime numbers are, students? First is 2, 3 and 5. So this representation is example of a roster form. Now the next one is set builder form. What do we do in set builder form? We write the property of the set basically. So in this, if I am writing it as x belongs to, so I am writing x is first 3 prime numbers. Okay, so first 3 prime numbers can be represented this in a statement form. Okay, now we'll take the example of a set builder form. As you can see here, that set builder form represents what? As I already told, that it represents the property. So for instance, we have to write in set builder form 2, 4 and 6. As you can see that I can represent it as 2 multiplied by n, where I can put values of n from ranging from 1 to 3. Okay, so I can directly write that x belongs to x equals to to n where n belongs to natural numbers, I have to specify the condition also where n ranges from 1 to 3. So you can note these three forms down, and you have to focus mainly on roster form and set builder form. Thank you. Hope we are through with this forms formation. Okay, now we are going to study what are types of sets. So what are types of sets? Basically, there are classification done on the basis of sets. So first one is empty set. As the name suggests, empty sets are those sets which do not contain any of the values. Okay, singleton set, as the name suggests, it consists of only one value. Okay, finite sets means a set which has limited number of elements in it. For instance, natural numbers up to 10. So I know that 1 to 10 are the natural numbers. I know I have a limited set of natural numbers in a set. Okay, infinite sets. So infinite sets, these are the values that are continuous and never ending. So if I'll write set of all natural numbers, set of all odd numbers, even numbers, so that will go up to infinity. Okay, equivalent sets. What are equivalent sets? So basically, if there are two sets, if they contain same number of elements, the elements must be different. It's not a mandatory thing that the elements must be same. So these are called as equivalent sets. So for instance, if the set A persists of the values of 1 to 3 and B persists colors like red, green and black, so as you can see, set A also has 3 values and set B also has 3 values. So I can say that this is an equivalent set. You can note these type of sets and then we'll proceed. I'll clean it up for you students. I hope you have noted it down. Now let's proceed further with another types of sets. So first one given here is equal set. So what equal set symbolizes? As I was saying that the name suggests the meaning of the set, the classification basically. So if there are two sets A and B, so here you can see that the elements are what? 1, 2, 3 and 4, and in B set also we have the same element, or irrespective of the order you have to check that the elements in A are similar in elements in B. So we can write that A is equals to B. So set A will be equal to set B. What are disjoint sets, students? Disjoint sets are those sets which do not have anything in common. So if I'll write that if A is equals to 1, 2, 3 and 4, and I'll write B is equals to 5, 6, 7 and 8. So if I'll find common in both of these sets, so there is nothing common, so this will be called as null or void set, or you can say this is an empty set. Okay, I hope you are following. Now the universal set. So what does universal set means? Universal set means it comprises of all the elements of the set that has been given to us. For instance, the set A comprises of elements like 1, 2, 3 and B comprises of 2, 3, 4 and 5. So universal set will comprise of all these elements and make sure that there is no repetition of the elements in the universal set. So 1, 2, 3, 4 and 5. So hope you have noted it down. Okay, I'm giving you time. I'll clear it up, students. Okay, students, let's proceed further. So what are subsets? And basically we'll talk about the subsets and supersets here. So subset is basically defined as the set which is in the set that has been given to us. For instance, if we have a set with 3 elements 1, 2, 3, so what will be the subset, students? Subsets will be 1, 1 and 2, 1, 2 and 3, and an empty subset. Empty set is also, my apologies, empty subset is also will be comprising in this set A. Okay, so this is denoted by this symbol, as you can note it down. So if it is not a subset, then you will put a slash sign on this belongs to sign. Okay, So you can note this down that we have number of elements. So you can write it down multiple also, 1, 1, 2, 1, 2, 3, and similarly 2, 3, 1, 3, and so on. So these are the number of subsets that are defined for the set of A that comprises of 3 elements, 1, 2, and 3. Okay, so you can note this down that a set is a subset of itself. So I can write here, if there are elements 1, 2, and 3, so A will be the subset of A. Okay, hope this is clear. You can note this down, students. I hope you are following and you are with me on this topic. Okay, now proper subset. What is a proper subset? So if elements of A is not equal to number of elements in B, so if we are comprising that B set persists of 3 elements, 2, 5, and 7. So if I am talking about a subset, so that will be 2, 5, 5, 7, and so on that we have studied in the previous slide. Okay. Now what is a superset, students? If there are two sets, let's suppose A and B, and if A comprises of all the elements that are in B, so that A subset or A will be said as the superset of B. For instance, you can see here that set A comprises of 4 elements, 1, 2, 3, and 4, and set B has 1, 3, and 4. So as you can see that all the elements of B are present in A. So A is said to be as the superset of B. Hope you are noting it down. You can note it down further and then we'll proceed. Okay, students, let's proceed further. So what are the operations that can be performed on sets? So first we'll see the union part, then we'll see the intersection part. Then let's suppose we have set A, so complement is represented with a dash. Cartesian products means the multiplication of the sets, and difference simply stands for A minus B or B minus A depending on the question as asked. Okay, hope you are with me. Okay, let's proceed further. Okay, now first is union of sets. So what does union of sets mean? So basically it's an addition of the sets A and B. Okay, so A union B will be standing for all the elements that are comprising in set A as well as in set B. So as you can see here that set A persists of 3 elements, 1, 2, 3, and for instance I have taken the example of 4, 5, 6 as set B. So I'll write A union B as what, students? I'll write A union B as 1, 2, 3, 4, 5, and 6. So you'll add up all the elements and you'll write in the union. For instance, I'll say that A comprises of element 1, 2, 3 and B comprises of elements 3, 5 and 6. So here you can see that 3 is common in both the sets. So you can see here that this area comprises of set A, this area comprises of set B, and this intersection is the common area. So what does common area, common intersection means? It means that the values that are common in both A and B will be written here. So I'll be writing 3 here and the remaining portion of A and B I'll be writing separately. So in A I'll be writing 1. I'll clean it off for your better understanding. Okay. So I can write what, students? I hope you are with me and following me. 1 and 2, and in 3 we have written in the intersection part, and this will be what? 5 and 6. Okay, you can note this down. Here you have to note this condition that X belongs to A and X will also belongs to B. Okay, students. Okay, students, I hope you are following and this seems to be pretty simple. We are just doing the basics. So intersection of sets. So as I have already told you that this region that belongs to both A and B is called as intersection of the set. Okay. Now there are certain properties that are written. So if A intersection B has been written, so you can also read it as B intersection A. Similarly, A intersection B intersection C is written. So what you can do, you can distribute the intersection part and then you can solve it further. So null set intersection A. So if there is any set and if we have to find common with the null set, then the answer would be null set because there is nothing common. Similarly, in union and intersection of any element, union stands for, as I was already saying to you, so that will be coming as A. And a element comprising of a set basically, so if I talk about two sets that are same, so A intersection A will always be A. So what you have to see in intersection part, that what things are coming common in the both sets. Okay students, note this down and then we'll proceed with the questionnaire parts after the topic. Okay students, let's proceed further. Now, complement of a set. What does complement of a set mean? That the portion which is not comprising in the set. So, if I'll write, if there are two sets given, so there are two sets A and B. So, if I'll say that not of A, so I'll write it as A complement. So, as you can see that this whole portion comprises of A. So, this will be comprising of not of A, means A complement, and similarly this universal set portion is also not coming under the circle of A, so whole intersection will be of B and this universal set. Okay, now you can see here there are some properties. So union of complement and the set will always be a universal set. So not of P and P will form it into the universal set. Okay, now the intersection of P and not of P. Okay, so if I have, let's take an example, if there is a set P1, 2 and 3, okay, and there is, so there is P dash, if I am saying that this is also comprising of 3 elements 4, 5 and 6. So if I'll do the intersection of them, so you can see that nothing is common, so this will be a null set. So as you can see on the board that complement of a complement will always give me that set. Okay, you can note this down students. So additionally the last law states that of an empty or a null set, so if I have a null set, so I'll find the complement of it, it will be coming to be as a universal set, and similarly complement of a universal set will give me a null set because there is nothing that goes outside the universal set. I hope you are following the statement. You can note this down students. Okay students, moving forward. So what's a Cartesian product and difference of sets? So Cartesian product stands that if I have two sets like A is comprising of 1 and 2 elements and B comprises of other 2 elements like ball and bat, for instance I am talking about. So Cartesian product is that you have to simply multiply the first element with the other elements of the set. Other elements of the other set. Similarly, you have to repeat this process. So I have written an example for you. So set A comprises of 3 elements 1, 2, 3 and set B has 2 elements, one is bat and ball. So combination will be 1 bat, okay, and 1 ball. Similarly 2 bat, 2 ball and so on. So you can note this down for your example. Okay, now what's a difference of sets? So difference of sets means you have to see what operation that you have been given. So if I am writing A minus B, so I have to see that what elements are left in set A after the common elements in A and B have been removed. For instance, there are two sets. A is comprising of 1, 2 and 3 and B comprises of 2, 3 and 4. So I am seeing here that 2 and 3 are common in both. Okay, so 2 and 3 will be eliminated and what element has been left in A? So only 1 is left. So the operation of A minus B, the answer would be 1. So what students, if I do B minus A, So I have to see what elements are common in B and A. So as we already know that 2 and 3 are common, but we have to see now with respect to set B. So in set B, as you can see, the element that is remaining is 4. So answer for B minus A will be 4 and A minus B will be 1. You have to note this down, that in which respect the operation has been given. Is it given A minus B or B minus A? And you have to answer accordingly. Okay students, you can note this down. Okay students, I hope you got the concept till now. Now let's move forward, where we have been given 3 sets A, B and C. Okay, so you have to figure it out which things, means which sets are coming in common in the intersection. So this portion is coming common in A and C, so this will be A intersection C. Similarly, B intersection C is coming common in B and C, and this portion, the middle region, is coming common in A, B and C cumulatively, so this will be written as A intersection B intersection C. Okay, now this portion, the upper portion, is coming common in A and B, so this will be written as A intersection B. Okay, now there are some set of formulas to find the number in intersection and as well as in the union. So you can note these formula down and then we'll proceed with the questionnaire part and the concepts. Okay students, now let's move forward. So these are the set of Venn diagrams that shows different categorization of union as well as for the intersection part. So this includes the complements parts and intersection as well as union. So as you must be knowing that the intersection part is the common part between A and B, so this will be shaded. A union B will be what? You have to shade the region which is coming as A plus B cumulatively. Okay, A complement is not, this should not be in A. So what should we do? The region that is not included in A will be comprising of A complement. Similarly, A intersection B complement, so we have to exclude the B portion as it is coming under the complement part. Similarly, A complement will exclude the A portion. Now A union, so this is the addition of B complement. So B complement means B would not be included but A portion will be included. So we will be taking intersection part also into consideration. Okay, now moving forward, the other part, this is A complement union B. So we will be taking B part into consideration and A portion that has to be excluded because we are taking complement into consideration. Similarly, A union B complement will be equals to what? A intersection B complement. So A intersection B complement will be what? This is coming as A intersection B and this whole region is also coming into this consideration. Last is A intersection B for the complements parts of both of them. So that will be considered as A union B complement. So whatever things are coming under this is similar to what? A union B complement. So you can see here that A union B, this whole region is shaded out, and A union B complement will be what? This whole outer region that will be considered as the universal set. You can note these questions down or pause this video. Okay, then we'll proceed further. Okay students, moving forward. So we have been given that universal set is given, and on this Venn diagram, I have to shade the region A union B. So as you must be knowing that A union B will comprise of the area that is under A and B collectively. Okay. Now moving forward, you can see here that the universal set is the natural number set that is less than 12. Okay. Now S is the set that represents the number 1, 4, 7 and 10. And similarly, T comprises of 1, 3, 5, 7, 9 and 11. So first of all, what you have to do, you have to see that what will come in this intersection part. In this intersection part, what things are common in set S and set T? You have to cut it down. So first I can see that 1 is common and 7 is common. I'll write 1 and 7 here. Now similarly, the elements that are left in S, I'll write in S. So that are 10 is already been written as you can see here, and I'll write the number as 4. Similarly for T, you can see that numbers are left 3, 5, 9 and 11. 3, 5, 9 and 11. Now you have to cross check that all the numbers that fit in this criteria have been noted in this set along with the universal set. So here I can see that the numbers that are less than 12 and comprise of natural numbers will range from 1 to 11. Now see here that 1 has been done. Now 2 is there, 3, 4, 5, 6 is not there, I'll write it down. 6 is not available. 7, 8, 9, 10 and 11. So as you can see that the number 6 is not under the set S or T. So we will write outside the sets, that is in the universal set. I can write here that is number 6. You can note this down, students, and then we'll proceed further. Okay students, moving forward. So the universal set is given as to be 1, 4, 5, 8, 9, 12, 60 and 64. So C is the set of cube numbers and S is the set of square numbers. So I have to arrange these in the given sets. So as you can see, you have to classify them as numbers which are coming under the category of cube and squares. So cube numbers, as I can see here, so only 8 is the cube number. Okay. So only number 8 is the cube number. Okay. Now square numbers I have to see. I can see here 1 is also the cube and 64 is a cube as well as a square. Okay. So what I'll do, I'll write 1 and 64 in the intersection part. Rest I have to take squares into consideration. So 4 is a square, 9 is a square and 16 is a square. So I'll write 9, 4 and 16. Okay, I hope you are getting the point. Now I am left with what? Now number 5 and number 12 we are left with. So these will be coming under what, students? These will be coming under the universal set. So I'll write 9 here and 12 here. Okay, so Venn diagram has been completed. Now I have to find what? C union S. So C union S is what? The number which is coming under the whole C union S. So you can count easily 1, 2, 3, 4, 5 and 6. So the answer for number of C union S will be what? Will be 6. Okay, this is a very simple question. Now moving forward, on this Venn diagram you have to shade the region of A intersection B. So A intersection B is what? The common area. So this will be the common area. Okay. So you can shade it directly. This will be the common area and this will be called as A intersection. Okay, I hope you have got the concept. You can note and then we'll proceed. Okay students, I hope you got the concept and the question. Now moving to the next question. So we have a set of W students who walk to the school. G stands for students who wear glasses. Okay, represented as G and W. There are 20 students in the class. So total number of class students is 20. So universal set will consist of 20 students. Okay. 3 wear glasses and walk to school. So this is basically a correlation between W and G. So I'll write here 3. Okay, I'll erase it. So this will be written as 3. Okay, now 8 walk to school. Okay, so this whole comprises of what? Walking to school. Students walking to school basically. So this portion is 3. So this portion will be what? This whole region would be what? 8 minus 3. So this will be coming as 5. Okay, I hope you are following. Now, 2 do not wear glasses and do not walk to school. So this is basically what? A set that doesn't comprises of any W or G. So the value will be lying in the universal set. So I'll write the value as 2. Now I have to find this value, basically the value of G, that is whole portion excluding the W part. So what I'll do, as I know that universal set is what? Universal set comprises of all the values. So I'll write this value as G. Okay. So this value is G. I'll be subtracting it from the universal set number. So this will be what, students? 20 is the whole number, minus I'll add 2, 3 and 5. So this is coming as to be what, students? 8 and 10. So the value, this value will be what, students? This value will be giving the value of G only. So the value of G is coming as to be 10. So you can apply basic mathematics for addition and subtraction and find the value of the given set. So I'll write the answer here as 10. Okay, I hope you got the concept. So this is 5, this is 3, 10 and this is 2. Okay, now moving forward. So I have to find the value of number B intersection A complement union C. So A complement union C you have to solve first. So A complement union C I have to shade. So A complement means the part should not be in A. So I will exclude and accordingly should not be basically comprising of the parameter A because I am taking not in A. So this 33 and 16 will be excluded. Okay. Now I will be left with the values what? I will be left with the values of whole. So this will be the region that will be coming under this A complement union C. So only values, excluded values I'll write, excluded values will be 33 and 16. Okay, hope you are following. Okay, now what I have to see here, I have to see that B intersection C. So what values are coming common in B and in the value that is shaded. Now you can see here that in B and C means the value that has come from this. So only values coming common are 10, 4 and 3. So the value of N B intersection A complement union C is what, students? Yes, it is 10 plus 4 plus 3. So this is 17. So what you have to do in these type of question, you have to first solve the other half and then you have to find cumulatively according to that and operate according to the second operation that has to be done with the second set. Okay, so you can shade the region and find the common number. You can note this down and then we'll proceed, students. Okay, students, now moving forward with the next set of questions. Okay, so I have to shade the region which is A union B complement. So I will exclude this part and shade the whole region. So we have to shade the whole region. So this will be the whole region excluding the region B. Okay. So what does A union B complement means? That we have to exclude this B portion and include whole universe and the means the universal set and the set A. Okay. Now use the set notation to describe the shaded region. So in this what we are saying that we are not taking P. So we are taking what? Complement of P. Similarly Q is also excluded. So we are taking Q complement. So taken considering the complements of both. So these both complements are intersecting with The region R means the set R. So what will be the notation, students? So R is intersecting with P complement, which is intersecting with Q complement. Okay, so you have to see which region we are taking into consideration. Okay, so we have come to the end of the chapter sets and Venn diagrams. You can practice more questions related to sets and Venn diagrams. That includes 3 figures or 2 figures, and conclude, and you can scroll down the video for further relevance. Thank you. Stay learned. Let's walk on the path of knowledge together by liking, sharing and subscribing to our channel.